Molecular mass and mole concept. Mass of the atoms of an element is known as its atomic mass. It is in fact the relative mass and is expressed in U. Relative atomic mass. The atomic mass standard is based on an atom of the isotope carbon-12. Standard atom of carbon is represented as carbon-12 atom 12C6. Mass of one carbon-12 atom is equal to 12U. If this carbon atom is cut into 12 equal pieces, then mass of one piece of carbon-12 is equal to 1 upon 12 times the mass of one carbon-12 atom, which is equal to 1 upon 12 multiplied by 12U. This is equal to 1U. Relative atomic mass is equal to mass of an atom divided by 1/12 of the mass of one carbon-12 atom. Let us explain relative atomic mass with the help of an example. We take a beam balance. Next, we place an atom of helium atom on one side. Now, in order to balance it, we place 4 parts 1 by 12 pieces of carbon atom. We know that relative atomic mass of a helium atom is 4. Therefore, the mass of one atom of helium is 4 times heavier than 1 upon 12 times the mass of an atom of carbon-12 taken as standard. Let us next try to find out relative atomic mass of magnesium atom. We place a magnesium atom on one pan and balance it with 2 carbon-12 atoms. So, we find that relative atomic mass of a magnesium atom is 24. This means that mass of one magnesium atom is 24 times heavier than 1 upon 12 of the mass of an atom of carbon-12. We know that certain elements have isotopes. Therefore, relative atomic mass of an element is the average mass of all isotopes of the element. This can be represented mathematically as relative mass of an element is equal to average mass of an atom of the element divided by 1/12 the mass of a carbon-12 atom. Let us take an example. Chlorine has 2 isotopes, chlorine 35 and chlorine 37 in the ratio of 3:1. Relative atomic mass of chlorine is equal to relative atomic mass of chlorine 35 multiplied by 3 plus relative atomic mass of chlorine 37 multiplied by 1 whole divided by 1 plus 3. This is equal to 35 multiplied by 3 plus 37 multiplied by 1 whole divided by 4. This again is equal to 35.5, which is not a whole number. We will now learn about relative molecular mass. Relative molecular mass of a molecule is equal to mass of a molecule divided by 1/12 the mass of a carbon-12 atom. Let us explain it with the help of a water molecule. If we place one water molecule on one arm of a beam balance and try to balance it with carbon-12 atoms, we find that we have to balance it with 1½ carbon atoms, that is, 18 pieces of carbon atoms. This means that relative molecular mass of a water molecule is 18. The mass of one water molecule is 18 times heavier than 1/12 times mass of an atom of carbon-12 atom. Let us now have a look at relative molecular masses, that is, sum of all relative atomic masses. Let us take an example of water H2O molecule. Relative molar mass of H2O is equal to 2 multiplied by atomic mass of hydrogen plus 1 multiplied by atomic mass of oxygen, which is equal to 2 multiplied by 1U plus 1 multiplied by 16U, which is equal to 18U. Relative molar mass of sulfur dioxide is equal to 1 multiplied by atomic mass of sulfur plus 2 multiplied by atomic mass of oxygen, which is equal to 1 multiplied by 32U plus 2 multiplied by 16U, which is equal to 64U. Relative molar mass of oxygen is equal to 2 into atomic mass of oxygen, which is equal to 2 into 16U, that is 32U. Next is carbon monoxide. Relative molar mass of carbon monoxide is equal to 1 multiplied by atomic mass of carbon plus 1 multiplied by atomic mass of oxygen, which is equal to 1 multiplied by 12U plus 1 multiplied by 16U, that is 28U. Let us now learn about gram molecular mass. The gram molecular mass of a substance may be defined as the molecular mass of substance expressed in grams, which is numerically equal to the relative molecular mass expressed in U. For example, gram molecular mass of ammonia NH3 is equal to 17 grams. Gram molecular mass of ethane C2H6 is equal to 30 grams. Let us try to solve a problem of whatever we have learned so far. Calculate the mass of 0.72 gram molecule of carbon dioxide. We know that relative molecular mass of carbon dioxide is equal to atomic mass of carbon plus 2 multiplied by atomic mass of oxygen, which is equal to 12U plus 2 multiplied by 16U, that is 44U. Gram molecular mass of carbon dioxide is equal to 44 grams. 1 gram molecule of carbon dioxide is equal to 44 grams. Therefore, 0.72 gram molecule of carbon dioxide is equal to 44 grams divided by 1 gram multiplied by 0.72 gram, that is 31.68 grams. We will now learn about relative formula mass, or RFM. Relative formula mass is the mass of one formula unit of an ionic compound compared to 1/12 of the mass of a carbon-12 atom. This means that RMF is equal to sum of relative atomic masses. Let us take an example of sodium sulfate. Relative formula mass of sodium sulfate is equal to 2 multiplied by relative atomic mass of sodium plus relative atomic mass of sulfur plus relative atomic mass of oxygen. This is equal to 2 multiplied by 23 plus 1 multiplied by 32 plus 4 multiplied by 16, which is equal to 142. Have a look at the calculation of the relative formula masses of some ionic compounds. For sodium chloride, the relative molecular mass is 58.5. Potassium oxide, relative molecular mass is 94. Copper chloride has a relative molecular mass of 135. Zinc nitrate, the relative molecular mass is 189. Aluminium sulfate, the relative molecular mass is 342. Hydrated copper sulfate, the relative molecular mass is 250. The gram atomic mass of carbon is 12 grams. The mass of one atom of carbon has been calculated as 1.9924 multiplied by 10 to the power minus 23 grams. The number of carbon atoms in 12 grams of carbon can be calculated as number of carbon atoms equal to gram atomic mass of carbon divided by mass of one carbon atom, which is equal to 12 divided by 1.9924 multiplied by 10 to the power minus 23, which is equal to 6.022 multiplied by 10 to the power 23. This number is known as Avogadro's number or Avogadro's constant and is denoted either as NO or Na. It may be noted that Avogadro's number of particles of any substance are expressed in the form of a term mole. In other words, a mole denotes Avogadro's number, that is, NO or Na of particles. Let us now try to understand about the mole concept with the help of an analogy. A pair is represented by 2. It can also be called a couple. Similarly, unity can be represented as 1. It can also be called a single unit. A baker's dozen is represented by 13. It is also called unlucky number. Similarly, 1 mole can be represented by 6.023 multiplied by 10 to the power 23, which is also known as the Avogadro's number. This means that 1 mole represents 6.023 multiplied by 10 to the power 23 molecules or ions or atoms. Let us now learn about the relationship between mole and gram atomic mass. If we take oxygen atom on the right-hand side of a beam balance and try to balance it with carbon atom, we find that it is balanced with 1 plus 1/3 carbon atom, which is equal to 16 atomic mass unit. This means that 6.023 multiplied by 10 to the power 23 number of oxygen atoms is equal to Avogadro's number are also equal to 16 grams of oxygen. Now, this is equal to 1 mole. Now, this is equal to 6.023 multiplied by 10 to the power 23 number of atoms, which is equal to 1 gram atomic weight. Let us take another example of a water molecule. One water molecule is equal to 18 atomic mass unit. This means that 6.023 multiplied by 10 to the power 23 number of water molecules will weigh 18 grams, which is equal to Avogadro's number. This also means that 1 mole is equal to 6.023 multiplied by 10 to the power 23 number of molecules is equal to 1 gram molecular weight. Let us explain this concept with the help of a beam balance. 1 mole of iron atoms will contain 6.023 multiplied by 10 to the power 23 number of atoms, which is equal to 56 grams of iron. 1 mole water molecules will contain 6.023 multiplied by 10 to the power 23 number of water molecules, which is equal to 18 grams of water. We will now solve a problem. Calculate the number of moles of iron in a sample containing 10 to the power 22 atoms of iron. Solution: number of moles is equal to number of atoms of iron divided by Avogadro's number of atoms, which is equal to 1 into 10 to the power 22 atoms divided by 6.022 multiplied by 10 to the power 23 atoms. That is 0.0166 mole. In using the term mole, it is essential to specify the kind of particles involved. For example, 1 mole of hydrogen atoms contains 6.022 multiplied by 10 to the power 23 atoms of hydrogen. But 1 mole of hydrogen molecules contains 6.022 multiplied by 10 to the power 23 molecules of hydrogen. In the text, one uses the word mole, but when used as a unit, it is expressed as mole. We will now learn about expressing a mass of substance in terms of moles. In case of elements, the number of moles is equal to given mass m divided by gram atomic mass. In case of compound, the number of moles is equal to given mass divided by gram atomic mass.